In the 1700s, man harnessed water and steam to start the Industrial Revolution. The Second Industrial Revolution brought us mass production, while the third increased industrial output through automation. We are now on the cusp of the Fourth Industrial Revolution, Industry 4.0, where industrial decision-making and logistics moves to the cyber-physical level. Previously, every step of design and production for electric, hydraulic, and pneumatic control systems were separate and autonomous. Mechanical or process engineers created designs requiring actuators for automated actions and installation steps. Electrical engineers created schematics with wiring and connectivity information for the devices to be installed in these automated steps. Between engineering and purchasing, all devices defined in the electrical schematics were ordered. Bills of materials were generated, purchasing departments often recreating orders for each device and supplier. Shop workers printed all necessary internal and wire and cable labels according to end customer specs. A panel builder or electrician identified the devices required, designed how to fit components in the smallest enclosure possible, and manually cut holes based on schematics. Panel builders or electricians utilized the schematics to assemble and wire the components inside the enclosure. Each wire was handled and marked off so all wires were installed correctly, or the controls would not work. Finally, everything outside the enclosure was wired to field devices. This was a labor-intensive process with multiple opportunities for errors and tremendous rework required for simple design changes. The Friedhelm-Loh group of companies works together to simplify and unite the design and manufacturing process, a major portion of Industry 4.0. E-Plan's computer-aided engineering environment enables designers to pull in an actuator along with its manufacturer-provided attributes, auto-populating the electrical and mechanical design with parts and creating a bill of materials that interacts with supply chain and inventory software. Component interfaces within the enclosure can then be simulated to ensure proper interaction and operation, and the design can be thermally simulated for excessive heat loads between components and within the enclosure, ensuring that finished products will function exactly as intended upon installation. Once the design is completed, a modular Rittal enclosure is selected for its ease in hardware and cooling systems installation. Adding custom holes and installing enclosure electronics is automated thanks to Kiesling's panel cutting and wiring machines. This interconnection simplifies the original design and enables automatic updating of the complete design if the first step ever changes. From wiring diagrams to custom holes, automatic updates tremendously decrease design iteration time. E-Plan also interacts with other manufacturers' equipment to increase efficiencies, like the Clip project from Phoenix Contact that automatically selects correct terminals and marks labels. E-Plan, Kiesling, and Rittal's tools can be used separately, but their greatest benefit is when used together synergistically. Spend less engineering time dealing with repetitive details and iterations and have faster production turnaround times via the innovative Industry 4.0 tools of the Friedhelm-Loh Group.